The purpose of this video is for you to look at the assessment that you took last week called Getting Things in Proportion Revisited and determine what things you did well that you're going to need to continue doing and what things you need to think about a little bit so that on your next assessment you're more successful with those skills. So I want you to start by taking a clean line sheet of notebook paper, and in the top right hand corner I want your first and last name, your period, you're either going to be period 1 or period 5, and the date 9/22/15. And then I want at the top of the paper you to have assessment number 1, reflection. When you've done that, you can move on to the next part of the video. So this is the method I used for the first problem about Sherry with her taxi cab, and I used making a table. So I labeled this miles and this cost, and that's something that some of you are and some of you are not doing. So take a minute to reflect on your paper about whether or not when you make a table you're remembering every single time to label what the X represents and what the Y represents. Explain that to me on your paper and then turn the video back on. Okay, so now it said that Sherry has to pay $4 even before she's driven any miles in the taxi, and that's probably because it costs money just for the taxi cab to come to your car, to your house, or to your work maybe, or wherever it is you're picking up a taxi from, maybe a restaurant. So this is what it costs just to get the taxi to you. Now it costs $1.50 per mile. So now I'd like you to reflect on whether or not you knew how to take this 4 and add $1.50 every time. So you're going to say, yes, I was able to make the table by starting at 4 and adding $1.50 yes every time, or I wasn't able to do that, and explain what you didn't understand if you weren't able to make the table properly. Turn the video off now and then don't turn it back on until you've answered that question. Now you'll notice when you keep the table going all the way out to 7, the answer is $14.50, and that was the correct answer to this problem. So if you were adding $1.50 every time and you got something other than $14.50, you need to figure out what you did wrong and explain what you did wrong on your reflection paper that you're writing on right now to me. This is a second method. And I like this method because I don't like having to take a table out 0, 1, 2, 3, 4, 5, 6, 7. It's easier for me to just plug it into an equation. So if you didn't use an equation, I want you to stop and write this down, and even if you did use the equation, I want you to stop the video and write this equation down. And before you turn the video back on, I want you to tell me what C represents and what X represents, and then turn the video back on and check yourself. Okay, so using the equation, C represents the total cost of the taxi ride, $1.50 represents the cost per mile, X represents the number of miles of the taxi ride, and the +4 is the charge that you have to pay just to get the taxi to go to your house. So to solve this problem, I'd have to do $1.50 times 7 miles, and then once I got that answer, I'd have to add 4 to that, and I still get the answer of $14.50. This is a much quicker way, especially when the table gets really big. You don't want to have to take that table out forever. It's much easier to think in writing equations. So this is the constant rate of change, the unit rate, and this was the starting point. The next problem talked about Ellie and buying cards, and again I labeled cards and I labeled cost. It's important to do that because I need to keep track of what the numbers that I'm using really represent. If that's a problem for you, it's something you need to write down. I need to work on keeping track of what things represent. So 0 to 4 here, and then they were adding 80 cents for every card, so plus 80, plus 80, plus 80, plus 80. Now you notice that I didn't take this table all the way out because I'm not willing to take this table from 0 to 13. I would rather use my equation method. So with the equation method, I write total cost C, is equal to 0.80x. Would you please write this equation down and label what the C represents and the X represents, and then turn the video back on and check yourself. Okay, so you should have written that C represents the total cost and X represents the number of cards. So in this case, if it's 80 cents per card, I have to do 80 cents times 13. And if you do that on your calculator, it's $10.40. The first thing I'd like you to do on this next problem is I'd like you to tell me whether or not you did some math work to change this 10-foot number into an inches number, or whether you tried to keep it as 10 feet while this was in inches. So I want you to turn the video off now and reflect on whether or not you paid attention to this being in feet and this being in inches. So it's either, yes, I paid attention and I changed it to inches by, or no, I didn't pay attention to the difference of the measurements. Turn the video off and turn it back on when you're done writing. Alright, so I made a table. This is the drawing width, and this is the real life width of the room. The drawing width is 4 inches, and in real life, in feet, the room is 10 feet. So the first thing I had to do is 10 times 12, because there's 12 inches in every foot. So 10 times 12 is going to give me my total inches. In other words, in real life, his room is 120 inches. Now I need to know what the unit rate is. In other words, I want to know how much 1 inch on the drawing is equal to in real life. So what I did is I took the 120 inches of his real life room and divided it by the 4 inches on the drawing, and I got 30 inches. In other words, he's using a ratio of 1 inch is equal to 30 inches. 1 inch on the drawing is equal to 30 inches in his real room. Now notice that 30 times 4 is 120, and 1 times 4 is 4. The fact that as this quadruples tells me this is proportional. Now I have to finish the problem. So here I have to go, okay, it's asking me about his length. Well, in the real world, his length of his room is 12 feet and 6 inches. I need to know how many total inches that is. So to figure that out, I go 12 times 12 equals 144 inches. Then I have to add the 6 inches long, because it's another 6 inches. That's 150 inches. Then I have to divide by 30, because every inch on the drawing is equal to 30 inches in real life, and that gives me 5. So in other words, the drawing will be 5 inches long. It'll be 4 inches wide by 5 inches long. Would you pause the video again and kind of write down how much of that you had done correctly and how much of it you still should have done, and make yourself some notes about what you should have done that you maybe didn't do. Don't turn the video back on until you finish that part. Question number 4 on the back of your paper talks about Fred going up on the elevator. And I started with a table, so this is floor and this is time in seconds. The first floor, and this is something we talked about in class, but some of you didn't change this. So if you didn't change this, if you left this as 10 seconds, one of the things you need to write down on your self-reflection paper is, I need to pay attention in class, because we went over how this wasn't 10, it was 0, because when you go into a building, you're on the first floor, you're not waiting for the elevator, it's right there at the first floor. So that's why this started at 0. We talked about that. Okay, and then it's adding 10 seconds every time, so 210, 320, 430. Now, when he gets to the 5th floor, you add 30 plus 10 is 40, but then you also have to do a minute for the people to get out. And a minute is 60 seconds, so you had to do 40 seconds plus 60 seconds equals 100 seconds total. And now I keep adding 10. 110, 7 will be 120, and so on. That's the first method. The second method would be to go 15 times 10, which is 150, and then add 60, which is 210. So I want you to stop the video again. This time what I want you to do is I want you to tell me how come I'm doing 15 times 10 instead of 16 times 10, since he's going 16 floors. And I also want you to tell me where this 60 came from. So how come I'm multiplying 15 times 10 and not 16? And where did this 60 come from? Turn the video off and answer those two questions. Okay, the answer to the first question is I'm multiplying 15 times 10 because even though he's going 16 floors, when he walks into the building, he's on the first floor and he doesn't wait that 10 seconds for the elevator. That's why I'm only multiplying 15 times 10. The 60 came from the 1 minute that it stops on the 5th floor to let people on and off. That's where that came from. Okay, so now I'm on the part that says if you double one quantity, you double the other. And the first thing I want you to do is I want you to stop the video and write down whether or not for 1, 2, and 4 you created tables in this column. I want you to write down, yes, I created tables that look like your tables, or no, I didn't. And then if you didn't create tables, again, it means you need to write yourself a note about paying attention, because we actually did the U-Haul John problem and I showed you that this was how I wanted you to do it. So would you turn the video off and reflect on how you did with making tables on this part of the test? Okay, so notice this is doubled, this is not doubled, so the answer is no. Notice this is doubled, this is also doubled, so the answer is yes. Here, if I go times 4, 1 inches to 4 inches, and then again times 4, 30 times 4 is 120. It's not doubling, but it's the same idea. It's quadrupling here, and it's also quadrupling here. And then over here, you had to be careful about the values. Some of you tried to pick 1 and 2 from the table, but that won't work because it's not right here. It looks like it is in proportion. It's not until you get here that it becomes out of proportion because of this minute of people getting on and off. So if you tried to use 1 and 2, then you weren't thinking about using values that would help you really answer the question and understand whether it's proportional. So I chose 3 and 6. 3 times 2 is 6, and 20 times 2 is not 110, so no. Over here you should have written down some ratios, and some of you don't seem to know where to grab the ratios from. So I want you to look at my ratios. I want you to stop the video and tell me whether you created ratios, and if you did you write what they were each equal to? And if not, I want you to jot yourself a note about, again, I need to pay attention because Mrs. Stephan showed us this. Stop the video and write me a little reflection piece there. Okay, so here you can see I'm just using the numbers from the table for my ratios. I could do 7 over 2 or 2 over 7, it doesn't matter. And I can do 10 over 4 or 4 over 10. Remember, this line says divide, so 2 divided by 7 on the calculator is about this, and 4 divided by 10 on the calculator is about 0.4. These are not the same, no. Here, 1 divided by 0.8 is 1.25, and 2 divided by 1.60 is 1.25, so yes. And here, 120 divided by 4 is 30, and 30 divided by 1 is 30, and last, 20 divided by 3 is 6 2/3, but 110 divided by 6 is 18 1/3. It's important to know where to get those ratios. Okay, so write down any final comments you have about how you did on the assessment and what kinds of things that you're going to try and work on between now and the next time we have an assessment, so that you're kind of keeping in mind a plan for success. If your plan is just to do as well as you did because you had 100%, then write down some things that you've been doing in class that have helped you be so successful.